Okay, we have this question under geometric progression. So since we are doing geometric progression, we are able to solve this kind of question. So the question reads: in a geometric progression, the third term is 16 and the fifth term is 4. Okay, calculate the first term and the common ratio, the 10th term, the sum to infinity. Okay, so for us to find the first term and the common ratio, we must know that the nth term of a geometric progression is given by the formula Tn is equals to a r to the power n minus 1. Tn is equals to a r to the power n minus 1. So in the question we have three important information. So we have the third term, which is equal to 16. We have been told that the third term is 16. So we have 16 down here, and the fifth term is 4. Okay, so for us to find the third term, we use the formula T3 is equals to AR to the power n, but we know that this is the third term, so the n will be 3 minus 1. Okay, like this. Okay, hence we remain with our T3, which is equal to AR squared. Okay, 3 minus 1 to give us 2, hence remain with AR squared. Okay, so we have been told that the third term is 16, so where this T3 we're going to replace with the 16. Okay, so we have 16 is equals to AR squared. Okay, so let's also do the same on the fifth term, which is 4. So we know that T5 is given by the formula, so T5 is the same as fifth term, is given by the formula AR to the power 5, where there is n, we put 5 minus 1, and so we're going to have T5 is equals to AR to the power 4, like this. Okay, so we know that our T5 is 4, so where there is T5, we're going to replace with 4. So we're going to have 4 is equals to AR to the power 4. So having these two equations, so we can name this as equation 1. We can also name this as equation 2. Having this equation, it's now easy for us to solve to find the first term and the common ratio, which is r. Okay, so here you should try by all means to make this equation look the same, like this equation. In short, they look the same. Try by all means to make it like this equation. So this equation can be also written as 4. Okay, so I've gotten this is equals to AR squared multiplied by R squared. So writing like this is the same as writing like this, because you know that when you're multiplying numbers or letters of the same base, you just add the power. So I'm going to have 2 plus 2, which should take you to this, which is 4. Okay, so when you pay attention to this and this, they are just the same. AR squared is the same as AR squared here, but we know the value of AR squared on our equation, which is 16. So where there is AR squared, we replace with 16 because we know the value of AR squared. So we're going to have 4 is equals to AR squared, you put 16 here, multiplied by R squared. Okay, then you make R the subject formula by dividing both sides by 16 by 16. So we're going to have 4 into 4, it's 1. 4 into 16, it's 4. Okay, is equals to R squared. This and this will go. Then you make R subject formula by introducing square root on them both sides. Okay, so this and this will cancel. We're going to remain with the R is equals to, what is the square root of 1? It's 1. The square root of 4, it's 2. So our R, it's 1 over 2. So since we have found our R, it's now easy for us to find our first term. Okay, so for you to find the first term, you can get this equation or this, just replace where there is R, you replace with the 1 over 2, which we have found. Okay, so let's get this, because this looks simpler compared to this, because this has a power of 4, this has squared. So I'm going to have 16 is equals to A multiplied by, where there is r, we replace with 1 over 2. So remember, this is squared. Okay, so we're going to have 16 is equals to a multiplied by 1 over 2 squared. It's 1 over 4. Then you make a as a substitute formula by dividing both sides by 1 over 4. So we're going to have 16 divide 1 over 4 is equals to a. Okay, a is equals to this. This will change from division sign to multiplication sign and then when it does that, this will go on top and this will come down. So we're going to have 16 multiplied by 4 over 1. So a is equals to 16 times 4, 16 multiplied by 4, to give you 64. So our first term is 64. So this is our first term. So the common ratio in the first term. Okay, so these are the 2 marks, and this is how it was supposed to be answered. Okay, we have this. So let's now find the 10th term. The 10th term. So you know that the 10th term, it's given by the formula T10. Okay, so this is 2. T10 is equals to AR to the power 10 minus 1. So T10 is equals to AR to the power 9. T10 is equals to our A, it's 64. We found our A to be 64 multiplied by our R, which is 1 over 2 to the power 9. Okay, so T10, which is the 10th term, is equals to 64 times so you just do 0.5 on your calculator to the power 9. It will give you 1.00 something like that. Then just multiply by 64. Okay, multiply by 64, hence it will give you your T10 to be 0.125. So this is the 10th term. Okay, so let's now just do the last question, which is the sum to infinity. Okay, find the sum to infinity. So you know that the sum to infinity, so we just write it here. Sum to infinity is given by the formula A, okay, over 1 minus r, when r is less than 1, but when it's greater than 1, you use the formula s, sum to infinity is equals to a over r minus 1. Okay, so since our r is 1 over 2, so that means that our r is less than 1, so we're going to go with this one. Okay, so we found our a to be, our first term to be 64 over 1 minus our r, which is 1 over 2. So here we're going to have sum to infinity is equals to 64 divide 1 minus 1 over 2. It give you 1 over 2. Okay, so 64 divide 0.5. 64 divide 0.5, it will give you 128. So our sum to infinity is equals to 128. So these are the answers to our question on geometry progression, which is the one we're from solving. So for those who may need online assistance, you can contact us on this line, plus this is WhatsApp, the WhatsApp line, plus 26099701136. So if you're watching this on TikTok, give it a follow and a like. If it's on YouTube, subscribe and share, because sharing is caring. I greet you.